pretty sure that you are quite familiar with the previous term and also activity. And I do believe that rather than using a small of or a pinch of something, using numbers in expressing the amount of something is the least ambiguous way. Agree? But now, how do we get those numbers? My name is Arsanti and today we are going to learn about measurement. So let's start with the definition of measurement. Measurement is a comparison of an unknown quantity or physical phenomena with a standard unit. Now we have to highlight two things. The first one is quantity and the second one is unit. What is unit and what is quantity? Quantity is a property that is being measured or the thing that we are going to measure. There are two types of quantity. The first one is base quantity or the fundamental quantity, and the second one is derived quantity. Just like its name, it is derived from the base quantity. The examples are mass, volume, and pressure. While unit is the standard measure of a quantity, and the examples are kilogram, second, and meter. Here I have one example. Arin's body weight is 168 centimeters. Yes, you can guess that body height here is the quantity or the things that is being measured. And we have the number here or the value which is 168 and the centimeter is the unit. As I mentioned before that there are two kinds of quantity. The first one is base quantity and the second one is the derived quantity. But today we will only learn about the base quantity. And here I have the international system of units for the base quantity. So these units can be used all around the world and there are 7 base quantities. So the first one is length and the unit is meter. And the second one is mass, the unit is kilogram. We also have time and the unit is second. Then we have electric current and the unit is ampere. Then there is temperature and the unit is Kelvin. Also amount of substance, the unit is mole, and the last light intensity and the unit is candela. For today, we are going to learn about 3 base quantity, which are length, mass, and also time. So let's start with the first base quantity. Length. Basically, length is a measurement of distance, and as I mentioned before that the international unit of length is meter. And the fun fact is that a meter is equal to the length of a path that is traveled by light in a vacuum during a time interval of 1 over 299,792,458 of a second. And you know that meter is not the only unit of expressing length. There are a lot of another units, and we can add prefix in front of the word meter so that we can easily express the bigger or even smaller number of the measurement. Here I have the stair of units conversion for length. It is started with kilometer, continued with hectometer, decameter, meter, decimeter, centimeter, and millimeter. How to convert from one unit to another unit? So every time you go downward for one step, you need to times the value by 10. And every time you go upward by one step, you need to divide it by 10. To make it clear, I have one example. So here I have 23.5 meter and I would like to convert it to millimeter. So from meter to millimeter, we are going downward for 3 steps, passing through decimeter, centimeter, and millimeter. So we need to times the number with 1000 and equals to 23 and 500 millimeters. Now how about going upward? Here I have 70,185 meter and I would like to convert it to hectometer. So we are going upstairs for 2 steps from meter passing through decameter and hectometer. So we need to divide the number with 100. And here what we got, 79.5 hectometer. Now I have several equipment that is usually being used to measure length. The first one is ruler. This one is quite familiar for you, right? It's quite easy to use the ruler and the reading. I'm pretty sure that you already know how to use it. So basically a ruler has several units on it. The smaller one usually expresses a millimeter, and the one with the bigger number usually expressed by centimeter. Several rulers also have an inch, and one ruler are usually 1 foot. The second one is vernier caliper. It's different with the ruler, so it have two kind of scale. The first one is the main scale, and the second one is the vernier scale. Now, how to read a vernier caliper? It's pretty easy. The first one, take a look at the main scale. We need to see in which number does the main scale is shown before the zero in the vernier scale. And for this case, we have 1.1 millimeter. So the unit is millimeter. And then take a look at the vernier scale. We need to find in which number does the vernier scale is in line with the main scale. And for this case, we are having the 7.1, right? But for the vernier scale, we are writing it as 0.07 millimeter. And we sum it up and resulting 1.17 millimeter. The accuracy for a vernier caliper is 0.01 millimeter. That's why we put the vernier scale in that way. And the last one is micrometer screw. It's not different from the vernier caliper, but now we have two types of scale. The first one is main scale and the second one is thimble scale, because how to use it is like a thimble, you need to scroll it. So first, to read the micrometer screw, again you need to see first the main scale. You have to see in which number the main scale is shown before this thimble scale. And for this case, we have 9.5 millimeters. And for the thimble scale, we need to put like 0 point something, and for this case, the one that is in line with the main scale is 36. So we are adding 0.36 millimeter. We just need to sum it up and we got 9.86 millimeter. Now coming up to the second base quantity, which is mass. So basically mass is a measurement of the amount of matter of an object. And as you know that international unit of mass is kilogram. And the fun fact is that a kilogram is equal to the mass of 1 liter of pure water. And similar with length, kilogram is not the only unit of mass. There are plenty of it, for example pounds, or ounce. But here we can also convert the units of mass by using the same way as we mentioned in the unit of length conversion. We can start from kilogram, hectogram, decagram, gram, decigram, centigram, and milligram. With the same way, so every time you go downward, you need to times it by 10, and every time you go upward, you need to divide it by 10. And one of the way to measure mass is by using 3-beam balance. It's quite easy actually. You just need to read the 3 beams. You just need to read the 3 numbers in the 3 beams. So from the upper one, we got 100, and then the second one we got 40, and the last one we got 2. You need to sum it up, and we got 142 grams. Now the last base quantity that we're going to learn is time. Basically, time is the measurement of a period. And as I mentioned before, that the international unit of time is second. And the fun fact is that 1 second is equal to 1 per 800 and the fun fact is that 1 second is equal to 1 per 86,400 of a day. So these are the example of the units of time. We have year, week, day, hour, minute, and second. We can also convert it like this. A year is equal to 52 weeks. A week is equal to 7 days. A day is equal to 24 hours. An hour is equal to 60 minutes. A minute is equal to 60 seconds. And we can do vice versa. And here I have one equipment to measure time. One of them is stopwatch. It's pretty easy to use stopwatch. You just need to press the stop and start button. But here we have several numbers here. The first one in the front one is a minute. And the second one is showing second. And the last and the smallest one is a millisecond or 1/100 second. So that's are the base quantities that we are going. So that's are the base quantity for today. Now, in getting the data of measurement and using the equipment, and in getting those data, we need to consider two things. The first one is accuracy and the second one is precision. What are the accuracy and precision? Accuracy is the closeness of measurements to the accepted or correct value. And if you get a great accuracy, it will resulting that your measurement will be close to the standard measurement. And if you get a great. Now, how about precision? Precision is the closeness of measurements to each other. As the result, your measurement will be similar every time you measure. Here I have the illustration of the accuracy and precision. The first one is a high accuracy with high precision. So for example, we are doing an archery and the arrow is showing like this. This is represent a high with high precision. So the target is close with the correct value or the target is close with the center of the circle. And every arrows are close to each other. It indicates the high precision. And then the second one, we have a low accuracy and high precision example. And as you see here that the arrows are quite far from the center and that is indicate a low accuracy, but the arrows are close to each other, so it's called as a high precision. And the third one, we have a high accuracy but low precision. So it is close to the target and indicate a high accuracy, but it's not really close to each other, the arrows. So it's called as a low precision. And the last one, this is the chaos one. It is show a low accuracy and low precision, where the arrows are not close to each other, yet it is not close with the target. So that is one of the things that you need to consider in doing a measurement. So today we have already learned about the measurements, the base quantities with the international standard units. We also learned about how to measure mass, length, and also time. And last, we learned about accuracy and precision in taking data for the measurement. To make sure that you get the ideas for today's learning, I have a small quiz for you. You can scan the QR code. So that's all for today. Thank you for watching and see you next time.